Okay, hello and welcome to the 33rd VJug session. And today we are welcoming back Arun Gupta, who this is your third session, so you've made 3 of the 33 possible. So thank you very much for coming back. How are you doing, Arun?
Thank you very much. As they say in the cricket land, it's a hat trick for me.
Absolutely, absolutely, yeah. And you're calling in from San Francisco again today?
That is correct. I'm good to be at home.
Awesome, awesome. And today with us as well, Oleg, head of Rebel Labs. How you doing?
Hello, guys, and I'm awesome. Have a great day. I'm very excited about this session. Looking forward to hearing it.
And you're going to be doing an interview with Arun straight after this session, so
correct.
that'll be available. That'll be available on Rebel Labs straight after that as well. Let me just while people are joining, and Oleg, would you mind just making sure everyone's joining correctly, making sure everyone's viewing? What I'm going to do very quickly is just share my screen, entire screen share. Okay, can you guys see my screen?
Yep.
Cool. So this is the virtual user group session on packaging your Java EE applications using Docker and Kubernetes. Today with us is Arun Gupta, as I mentioned. You're welcome to follow Arun. I think there's a space in that Twitter tag. Let me just update that quickly. But you are at Arun Gupta. There we go.
Yep.
At Arun Gupta on Twitter. So you can join Arun's already, I think, about 150,000 strong Twitter followers already. The Virtual Jug is sponsored by Zero Turnaround, and our media partner is Rebel Labs. Just a quick word about them before we start. Zero Turnaround produce revolutionary developer tools, and 2 of which are JRebel, a tool which allows you to reload your code changes instantly, so you can develop your code in your IDE and then see them instantly in your runtime without a deployment or restart. And XRebel, which is a new lightweight Java profiler which allows you to find issues and bugs you would normally find in production during your development. For the session today, we're going to be on IRC as normal in Freenode hash virtual jug or pound virtual jug. Please do share the session on Twitter, Facebook, with your friends, family. Tell your mum and dad, your brothers and sisters, everything. We're a growing community, and we love to grow. Also, if you have any feedback about the session or the group, please ping me at virtualjug or at sjmaple on Twitter. And if you enjoyed the newsletter that I recently sent out, or have some updates that you'd like to see in that, please do let me know. So, without further ado, Oleg, I assume everyone's connecting and everything's good.
Yeah, I verified myself. So virtualjug.com/#live. The session is working, and people in the IRC chat has also support this claim that it is working. So we're good to go.
Excellent, excellent. So I'll hand straight over. Arun, let's talk about containers.
All right, man, let's do it. I'm going to share my screen, share my entire screen, and I'm going to switch here. All right, super exciting. Okay, my name is Arun Gupta, and I work for Red Hat. Whoa. I automatically move to the next one. Today we're going to talk about packaging your Java EE applications using Docker and Kubernetes. Well, this is the only marketing slide which says Red Hat and JBoss middleware. Everything else is going to be all technology. I work for Red Hat. I'm the director for developer advocacy. That means anything and everything to do with developer outreach for Red Hat. For JBoss middleware, I'm responsible. You can follow me on Arun Gupta. I got a comprehensive blog, blog.arungupta.me, and you can reach out to me, arungupta@redhat.com or gmail.com. Either way is fine. All right, let's see, what is Docker? So I'm not going to go into the history and the background of it, but Docker effectively is an open source project and a company. So it's a company backed by an open source project. You can go to github.com/docker/docker. Well, github.com/docker is an organization on which there are multiple projects, of which Docker is one of them. So you can see the number of stars, the number of forks, the number of watches it's got, the number of commits. So the project is pretty strong, a lot of traction, and hopefully today I'll be able to show some of the reasons on why Docker is so popular. Well, what does it do? Well, it allows you to create containers for software applications. So hang into the word container for a second. It's got multiple meanings, and I'll explain that in our context. What do we mean by containers? Now, Java provides the programming model of Vora, which is write once, run anywhere. With Docker or containers, I call them as PODA, or package once, deploy anywhere. The whole advantage of containers really is you can package your application once, and as long as you have a Docker environment running on your operating system, the entire Docker image can be easily run over there. So essentially, you package all your dependencies, your app server, your databases, etc., together as Docker images, so to say, and we'll talk about images in a second. And you package them as a Docker image, and you run them as a Docker container. Okay. So what does it do? What's the advantage in general of container or Docker for that sake? So Docker basically brings in an API for container management. How do you manage your container? An image format, how your Docker image is going to look like, and a possibility to use a remote registry for sharing containers. So those are sort of the three different aspects of it, API, image, format, and registry. Now, this scheme benefits both developers and system administrators with several advantages. First one, faster deployments. Now, Docker relies upon augmented file system. So what that means is the very first layer is read-only. On top of that, there is another read-only layer. That's how the base OS is being built. On top of that, if you want to write anything, you basically create a read-only layer. Now imagine those bunch of read-only layers that are put together, and effectively you are augmenting all of them together to give you a file system feeling. And that's what really gives you a faster deployment, because the previous layers are read-only. Only the newer and updated components need to be deployed. On a personal server, you will probably want to run applications with different requirements. Okay, so you might need, say, Apache or Nginx, different version of Java, other programming languages, databases, JBoss application servers, whatever you want to use. Trying to get all of these, trying to get all of these running on the same server natively can be tricky, to say the least. With Docker containers, you simply package up the requirements for a given application, and nothing will interfere with anything else. And you will understand that nothing part in a second as well. The typical problem in development is, or in your software lifecycle is, hey, it works on my machine, it's a bug on your machine. So that's where Docker gives you excellent portability across machines. Effectively, what you do is you bundle up all of your applications and its dependencies into a single container that is independent from the host version of Linux kernel, platform distribution, or deployment model. Now, this container can be transferred to another machine that runs Docker and executed there without portability, compatibility issues. So effectively, it reduces your impedance mismatch. Now, you can track successive versions of a container, inspect differences between different versions, or roll back to previous versions. Imagine that a new version of an application comes out. So you try it out, but you really don't like the new UI that has been introduced. Well, how do you roll back in a conventionally deployed application? You go back to a var and you figure out the dependencies, etc. In this case, you just switch back to the previous Docker version and use the previous image in a matter of seconds. Containers also allow you to sandbox your applications. So Docker provides better security than regular process isolation. So if an application is hacked, it won't affect the rest of the server. Another cool part about Docker is how it allows you to restrict your resource usage. It makes it easy to limit the CPU and the memory available to an application. This way, a rogue process or a traffic spike on your blog won't necessarily bring down your whole VM. When I say VM, I don't really mean the Docker VM, JVM or whatever it is. So VM is a very generic term in that sense. It has the dependency model is very easy here because you are specifying all the dependencies in a Docker image, and we'll talk about that in a second. And it's all listed in that image. There is no documentation that some human needs to follow, which could possibly be erroneous. You can use a remote repository to share your container with others. So there's a Docker Hub, which we'll talk about in a second, which is public registry. Red Hat also provides a registry for this purpose, and it's also possible to configure your own private registry or repository. For example, JFrog, they provide a private registry where you can host your Docker hubs or Docker images. So let's talk a little bit about the underlying technology. Well, first of all, Docker itself is written in Go programming language. If you go to the project, you look at the language variations, you can see there is 88% written in Go, which is a programming language by Google primarily, and then there are a bunch of other languages as well. But as you can see, most of the work is done in Go. And it uses several Linux features. It really is mostly dependent upon Linux. So for example, Linux has this concept of namespaces that allows you to provide isolation. Applications running in one namespace do not interfere with applications running in another namespace. It also has this concept of control groups that share and limit hardware resources. That's exactly what Docker uses to restrict your resource usage. We talked about union file system a little bit. That's what makes Docker light and fast. And then libcontainer is a concept in the Linux world which defines a container format on how on-the-wire format of Docker would look like. Okay. Now, excuse me. It is reliant upon a lot of Linux features, but does that mean it is only Linux? Well, that's not true. It is natively supported in Linux, but on a Mac or a Windows, what you can do is you can install a boot to Docker VM. Now, as a matter of fact, all my development on Docker and Kubernetes and so on is done using boot to Docker on a Mac. And there are people within Red Hat who are doing it on Windows just to make sure that it works. Okay. Essentially, boot to Docker gives you a tiny core Linux VM, and it gives you that Docker environment on whatever operating system you're running. So let's take an understanding on how Docker is slightly different from the virtual machines. And it's a big difference, actually, by the way. So if you see on the top, typically you have a server on which you have a host operating system. So let's say this is my Mac. This is a Mac OS. I will install a hypervisor. VirtualBox is a type 2 hypervisor, so I might have installed it over here. Then on top of that, I will have multiple guest operating systems. So I could run Windows, you can run Linux, Fedora, whatever. I can run a variety of guest operating system. Each guest operating system has its own binaries, libraries, and applications, etc. In order to make these guys talk to each other, it requires sophisticated networking. Docker, on the other hand, is server, host operating system, and then you have a Docker engine running. Now, and as I said, in case of Mac and Windows, this Docker engine is running in a VM by itself, but that's because it requires those features in there. But once you have the Docker engine running, you can have your bins, libraries, and application all packaged up together as a Docker image, and that's it. It just relies upon the underlying Docker engine and the capabilities to delegate it and get the job done. So what are the three key components of Docker? All right, so build, ship, and run. Now, as part of build, what you do is you essentially build your Docker image, which says you define what are the dependencies, you define how, what version of JDK, what version of application server, what version of database, etc. is required. You build a Docker image with that. Now, once you have built the Docker image, you may want to ship it. That means you want to share it with somebody else. Could be dev to QA, QA to prod, prod to scalability, different teams, whatever it is. And that's where the ship component of Docker comes in, which is basically done using registries, and which is what I talked about. So for example, Red Hat has a Docker registry. JFrog offers also another registry, and of course there is Docker Hub for public sharing. And last but not the least, excuse me, there is Docker Run, which allows you to run a Docker image, as a container. Now, you always want to think of Docker image as the static thing, and Docker container as a runtime representation of that static image. Okay. So build, ship, and run are the three key components of Docker. Let's take a look at them in a little bit detail before we jump into looking at the recipes of Docker. Now, a Docker image is defined in a text-based file called as Docker file. Now, that's the default name. Of course, you can override it, but default name is Docker file. This is my most canonical file. So literally, if I put these text saying from Fedora latest command echo hello world, That's my Docker image. And all I can do is put this in a Docker file, and I say Docker run. Effectively, what I'm saying here is pick up the latest Fedora image. Now, there's a default Fedora image that exists in the Docker Registry or Docker Hub, and I'm saying run this command. So if I'm just going to pick this image, run it, all it's going to do is pick up the latest Fedora, run hello world, and exit out. That's it. Very canonical example, but at least get you the thought process through. Now, I can build this, I can have this file locally, where I can say Docker build, or somebody might have pushed this image on the Docker Hub, in which case I say Docker pull. Now, Docker is the command, which is the command line tool on the client side by which you interact with the Docker Hub or Docker daemon. Okay. Now, we talked about how images are shared using Docker Registry. So yeah, Docker Registry is good. Docker Hub, as we talked about, is a public SaaS. So you go to registry.hub.docker.com. You can search a whole bunch of Docker images that are available over there, and there are thousands of images that are available. Every software component, they want to push out their Docker images over there. But the key difference is, you have the capability to do a private registry as well. So as I said, Red Hat has a concept of private registry, which you can set up inside your firewall. One of the issues that you want to be aware of in a Docker Hub is if you are doing a Docker pull, there is really no validation that's happening at that point of time. This could be a rogue image, for example. So Red Hat has this concept of a container development kit, which allows you to certify container Docker images and say, oh, this is certified by so-and-so vendor, and I trust in this image more than anything else. I think that's an important concept to understand as well. But effectively, once you have found the image, all you say is Docker push or pull. You give it an image ID or name, and it will download the image from the Docker Hub onto your local host on wherever your Docker client is running. Now, the container themselves are built from the image. It's a pretty solid representation. This container really represents isolation, snapshotting, security, all those good things that come with the container. And it really is a runtime representation of the image. Excuse me. It's a fully self-contained execution environment. That means it does not really depend upon another Docker image. I mean, you can create that explicitly, but not by default. Anything that you need to have that Docker image running as a container, whether it's JDK database, you're going to specify that as part of that image itself. And I'll show you an example of a little bit more comprehensive image to get you a better idea. Now, once you have the image, then you say Docker run image ID, and boom, you got the image running here. Now, Docker is the client that I talked about. It has a bunch of commands. So ps lists the running containers. Similarly, you can say Docker images. It shows the list of images. You can stop a running container. You can remove a running container, remove an image. So there are complete details available on the URL at the bottom of the screen, which says, how do you get started with Docker? What are the commands that are available over there? So let's take a look at the Docker workflow before we actually start digging into the details. Well, I got a Docker client. I got a Docker host, which is running, say, in my boot to Docker VM on my Mac here. And I got a Docker hub, which is public. So Docker client says, I want to run a Docker image. All right. It gives that command to Docker host, which is my daemon process running. It says, hey, I don't have that image, so let me go talk to Docker Hub and download that image. Docker Hub has a lot of images together, anything from 1 to m being a random number. So depending upon what image, if the image does not exist on the Docker Hub or Docker host, it's going to download that image from the Docker Hub to Docker host, and it's going to run it. Now, green box container, now remember, the difference is image is the build representation, container is a runtime representation. So that's why it's shown in a different color. So you are running that container on the Docker host. And then you can communicate with that container with the commands that I showed in the previous slide. Excuse me. So let's take a look at a little bit more elaborate Docker file. Now, this is a fully functional Docker image. What I want to highlight here is how you can create a hierarchy of images. So this is, I'm using CentOS. So from CentOS, I'm running, this is just a maintainer tag, but I'm running update here. Then I'm installing the packages that are required to run EAP or Wildfly. I'm adding a user group. I'm setting up a work directory. As a root, I'm installing JDK here. Then I'm changing the user. Then I'm setting the environment variables. Then I'm downloading the appropriate version of Wildfly. Then I'm exposing the ports, and then I'm firing up Wildfly. So very simple. You just have to have this text file, and once you have the Docker environment set up, you can say Docker build. This will build the Docker image, and then it's a Docker run, and it'll run the image. Or I already have this image set up in my Docker Hub, so I'll show you how to access this image. But essentially, if you run this image, it'll fire up Wildfly for you in a few seconds, literally a couple of seconds. All right, so let's take a look at the first Docker recipe that we want to talk about today. Excuse me, guys, I'm having a little bit of cold today. So we talked about the hierarchy part of it. Now, we have the image that I showed you last time is a JBoss, well, it's an image that I created from CentOS, but we like our formal images to be from Fedora. So we have this image called as JBoss Wildfly, which is created by the JBoss team. So that's the default image, that's the standard image that we want everybody to use. So literally in this one image, this is the full image, by the way. All I'm doing is from JBoss Wildfly, and I know there is some things that are being done as part of the JBoss Wildfly image, which exists in Docker Hub already. All I'm doing is downloading the Java EE 7 hands-on lab, the pre-created WAR file, and dropping it into the deployments directory of Wildfly. Okay. This image is already pushed on Docker Hub as Arun Gupta /Java EE 7-HOL. Now, what's happening in this case is you have a host. On the host, you're running application server, and you are using an in-memory database. So that's sort of the recipe that you're using. It's quick to get started from development. And if I walk you through the command here, I'm saying Docker run. I'm saying run it with a TTY. Then I do a port forwarding. Remember, we were pushing out port 8080, exposing port 8080. Now I'm port forwarding so that it's available on my host as well. So I say Docker run it-peep 8080, and then an image name. Okay, so let's take a look at this now. So if I go to my terminal here, here I see Docker PS. There are a bunch of Docker containers running, but effectively, if I say Docker run, and I run it in an interactive mode, and I do port forwarding, all I say is Arun Gupta /Java EE 7-HOL. I fire it. It's going to start up my Wildfly basically. It's going to deploy my Java EE 7 application. You can see the commands over here for deployment. It's trying to drop the database table, which don't exist, and it gives an error for that. And that's it. It's live now. Now, if I go to my browser here, and if I say, well, on this Mac, I'm running boot to Docker VM. So I got to get the IP address of the boot to Docker VM. And once I get that, which is this IP address over here, then I just need to access my application here. Ta-da! So just by Docker run command, I got that simple Java EE 7 application up and running over here. Very easy to demonstrate, in a demo environment or to get started. All right, so that's my recipe 1.1. That's good for development, but as soon as my application server goes down, my database goes down, so everything is lost. So that's where my recipe 2 comes in. Here I'm starting up my SQL server explicitly. So all I'm saying is Docker run name. I'm giving some SQL, MySQL variables that it requires, and then the image name. Okay. So this is going to fire up a database and an application server on the same host. I'm running a boot to Docker VM here, so that's my host, and on that, basically, I'm going to run 2 Docker containers. So this is still the same host. Now, Docker has this concept of container linking, okay, and that's what I'm using here. I'm saying when I'm running my Wildfly container, I'm saying, oh, by the way, link it up, the MySQL DB container. This is the name of the container here, and I want you to link it up over here and expose it as DB name in my container, my wildfly. Now, as soon as I expose this name, as soon as I link the containers, the Docker linking concept defines this. Docker linking defines this concept of environment variables. It automatically exposes these environment variables. So it says DB port 3306 TCP address and TCP port. So basically, host and port are available to me now. And essentially, what I'm doing is now in my wildfly, when I'm adding my JDBC resource, I can actually use these host and port variables. And there you go. So I got my application server and database decoupled now, but they're still on the same host. That's my recipe 1.2. Now, 1 basically indicates as a Docker recipe. In order to simplify that, now that's too much linking commands to remember. Then there is fig. That's recipe 1.3. I'm still running on the same host, application server database, as 2 separate containers on the same host. But this case I'm doing is I'm creating a fig.yaml file. By the way, all throughout you will see blog references. So if you click on that, it will actually get more details on how to reproduce these recipes in your own environment. Now, I have the fig.yaml file. I'm specifying my SQLDB, my wildfly here. All the environment variables, etc., are specified here. Image names are specified here. Exposed ports are available over here. All I need to do is fig up. I just basically up the containers, and I run it in a detached mode, and that's it. So that's sort of your third recipe on how you can package up and run your applications very easily using Docker. That's still on the same host, and now that's not a true solution. So how do you do this on 2 different hosts? Well, there you go. So that's your fourth recipe. So what you're doing is you are still running Docker run, providing MySQL user variables, image name. Now, once you have run it on a container, you can actually obtain an IP address. So in this case, I'm running 1 boot to Docker VM, but if I could run 2 boot to Docker VM and I can somehow figure out their IP addresses, then what I can do is when I'm creating my data source, at that point of time, I can say, oh, when you're creating the connection URL, use a MySQL host and port. And when you're running your my wildfly image, at that point of time, you can specify the host and port explicitly of a different host and port. So you're not using container linking here because that's not going to work, but you're explicitly specifying a host and port that allows you to link containers across hosts. Now, Docker has this concept of ambassador containers, but that seems like a redundant step at this point of time, and I'm not sure if that's the optimal solution in my opinion. So that's your 4 recipes of Docker. So this is how these 2 guys are linked. Now, that's good. Now I got my applications up and running on Docker. How do I test these applications? I'm used to, say, Arquillian. I'm used to Maven test, JUnit style of testing. Well, that's where exactly Arquillian Cube comes in. Arquillian, if you guys are familiar with it, it provides a fully integrated container-agnostic testing for Java EE applications. Now, Arquillian Cube is just an extension for Arquillian, basically a Maven dependency. It controls the life cycle of Docker images as part of the test cycle. Just like it can do it automatically or manually. You can tell Arquillian what to do. Effectively, Docker containers has a REST API, and that's what Arquillian Cube uses to talk to the container. And then within the container, it uses, for example, the first version of Arquillian Cube is enabling to run your images on Wildfly. So for now, it's using the Wildfly remote adapter to talk to the container. Now, all the Java EE 7 samples, and there are about 200 of those. I hate to call them samples because these are really samples / tests / guidelines, whatever you may call, blueprints, whatever you may call them as. But there are about 200 plus samples over there. So you can git clone them on the Docker branch. You can run any of the tests using Arquillian Cube. So I would highly encourage you to take a look at it. For now, it runs on Wildfly Docker Arquillian profile. But yeah, once we add Glassfish and other profiles for Arquillian Cube, then you should be able to do that as well. So let's understand some of the Docker pros and cons. Now, Docker does give you extreme application portability. We saw that, how all the dependencies are specified in the Docker file. Very easy to create and work with derivative. You can say, this is my base image. On the base image, I'm going to add JDK. Then I'm going to create another base image. So you can create a hierarchy of images. This will fit very well in an organizational structure. And you saw how fast the container really booted without installing and everything. So that's pretty cool. However, it's a very host-centric solution. Docker linking is good, but restricted only to Docker same host. There is no higher level provisioning. If I want to create multiple Docker images, do I do that myself? What if I want to create a cluster of 10 Docker images? How do I do that? Who does it for me? What if I want to manage them, like auto scale or manually scale them? So there is no higher level reporting, tracking, etc. that's available. All right. So Docker is good, but that's part of the solution. Excuse me. So let's take a look at it. Now, this is my typical, what I call it as an application operating environment. I might have multiple Wildfly instances, JDK, RHEL, Fedora, MySQL, MongoDB maybe, Apache, some messaging server, some InfiniSpan, all that typical application stack. How do I get that going? Well, welcome to the world of Kubernetes. Now, Kubernetes is an open source orchestration system for Docker containers. Now, remember, this is not for generic containers. It is for Docker containers. It's a project led by Google. One of the cool things, one of the most appealing thing of Kubernetes really is how it allows you to provide declarative primitives for the desired state. So, for example, you don't need to say run 5 containers. You want to say, what you say is, I want to have 5 Wildfly instances running and 3 MySQL instances running. Now, if the instances go up or down, and if the instances go down, Kubernetes itself is responsible for bringing those instances back up. So that's what you mean by the desired state, that you say the state that you want to be in, and Kubernetes ensures that state is there. And that's where your self-healing, auto-restarting capabilities of Kubernetes are very, very powerful. And I think that's the most appealing feature of Kubernetes. Of course, it works across multiple hosts, which is sort of a basic limitation of Docker. As I said, the ambassador container linking is it's sort of a workaround, like a hack to me. And it allows you to do replication as well. So you can say, hey, here is my Docker image template. Just replicate it on multiple locations, as many times. Sort of a cookie cutter approach. As I said, the project is led by Google, but Red Hat is very actively contributing to this. So this is a snapshot from about a couple of days back, and you can see Smart Clayton and Derek Wayne Carr. These are the 2 Red Hat developers. So we are very actively contributing to the project in that sense. And I'll share more details about how we are using Kubernetes within Red Hat. So give me a break while I grab a sip of water. Thank you. So let's understand some of the Kubernetes concepts. Now, Kubernetes has this concept of a pod. Pod is the smallest logical unit, which is a collection of containers that share an IP and a storage volume. So you can say, well, what I'm showing here is you have a Docker container running. In a Docker container, you could say, well, a Docker environment running, not a Docker container, but you have a Docker environment, Docker host running. And then you can say on the Docker host, run multiple pods, and each pod could have 1 or more containers. Now, pods are ephemeral, and one of the basic requirements of Kubernetes is each pod should have an IP address. Everything should be addressable using an IP address. But the pods and the IP address assigned to them are ephemeral. So that means you cannot really refer to them. If a pod goes down, Kubernetes might restart it and assign it a different IP address. Well, that's where your service concept comes in handy. It's a single stable name for a set of pods together. you can say I got two pods, JBoss pod 1, JBoss pod 2. They're both exposing port 80, and they're being front-ended by a service web. It also acts as a load balancer. Now you can also there's a concept of a replication controller, so which says, okay, I don't want to create a pod, but I want to create a replication controller, and the number of replicas are 5, and here is my pod template. So it basically ensures it manages the life cycle of a pod effectively, and ensures that a specified number is running. So nothing less, nothing more. But you say run a replication controller with so many pods, it ensures that that is running. Single host, multiple hosts, it purely depends upon Kubernetes. And another important concept of Kubernetes is labels. So you need to understand that everything, pod, service, they all talk to each other using labels. Everything is assigned a label, and there is this etcd daemon which allows you, which is a distributed global name value repository, how you can share labels, and it is being watched by Kubernetes master. Okay. Now, another thing that you want to understand as part of Kubernetes is kubectl. This is sort of the primary script. Just like in Docker, we had the Docker script. Here we have kubectl, which basically controls the Kubernetes cluster manager. So you create a Kubernetes cluster that could span across multiple hosts, and kubectl is responsible for doing all that. Now, using kubectl, you can create, you can get the pods, or another terminology is minions. And I've heard sort of conflicting comments whether it's minions or nodes. The terminology keeps changing, but let's stick with minions for now. So you can say kubectl get the pods or the minions. Minions are the hosts that are running on which the pods are going to run. Effectively, for Kubernetes, if you want to create a pod or you want to create a service, it requires a configuration file. And everything is done using a REST API. So all you say is kubectl create -f and give it a file name. And now it's going to create that particular resource for you. So completely REST driven in that sense. Similarly, it's a REST, it's a CRUD pattern, so you can update or delete. You can create a replication controller, and you can resize dynamically, by the way, by changing the number of replicas. So that's pretty cool. I'm a Mac guy, so how do I run Kubernetes on my environment then? Well, Kubernetes, of course, natively supported on Linux, but what you could do is, on your Mac environment, you can set up export Kubernetes provider Vagrant, and then you say cluster kube up. Well, of course, you need to check out the Kubernetes workspace, build it, or download the binaries. I like building the workspace. I can do that once a week or so. But once you run it up, by default, it starts. So here is my Mac. On my Mac, I have my Kubernetes cluster running using Vagrant, and I got a Kubernetes master and a minion. Now I got a few VMs running here, but because this is running using Vagrant, by default Vagrant uses VirtualBox. So I got my Kubernetes master and a minion running over here nicely. All right, so let's look at my very first recipe for Kubernetes in that case. So here is my Kubernetes configuration file. Now in this file, I'm saying, okay, take the same Java E7 HOL file. I can probably get rid of these ports. I can definitely simplify this file. But I'm saying take this file, expose these ports, and I'm saying the kind is a pod. Okay. So effectively, on the Kubernetes cluster, well, by default, it runs a master and a minion. You can configure it to run multiple minions or multiple nodes. So when you say create -f, this using this configuration file is going to create a pod for me. On that pod, I'm running a Docker container, which is a wildfly container, which is using this image. So that's pretty straightforward. Okay. Now, well, you know what? Let's do that actually. Here I am. I'm going to stop this Docker container here. Okay. I'm going to move it up so that you guys can see it here nicely. So this is my Kubernetes. Okay. So if I go back here, here, all I'm going to do is refer to this configuration file and spin up my Java EE 7 hands-on lab. Okay, and the way I do that is I say cluster, I say kubectl, and I say create, and I give it a file name, and I have Kubernetes Java sample, and I say Java EE7 hol.json. Okay, so this is gonna create the resource for me, and it says pod wildfly already exists. So all I can do is I can say cluster kubectl get pods. So show me the pods. Oh, it shows the pod already exists. Now, again, very RESTful API. So you're saying, getting me the list of pods. You know, it gives you. It's funky. You know, you can't really customize. I haven't figured out how to customize the number of columns that needs to be shown. But here, basically, it's saying the container, the image name, and the host. So now, if I take this host and I replace this IP address with this host here, and my image is now running inside Kubernetes. Now remember, we were talking about our self-healing infrastructure, okay? So what we do is, I'm going to go into minion 1. Well, let's look at this first of all. If I see vagrant status, it shows there's a master running and there's a minion 1 running, okay? So now what I'm going to do is, I'm going to go into minion 1 because all the pods are running on minions. So I vagrant into minion, okay? Then I do into root, and I say, show me the Docker containers running here. Well, here it says, these are all Kubernetes Docker containers. This is my container, okay? So what I'm going to do is, I am going to say, go ahead, take this container and kill it. That could happen. Like, remember the simian army that comes from Netflix that can kill this container. There we go. So I just went ahead and killed the container. And now when I see the container or the pods, that pod is gone, okay? And if I go ahead, try to access my application, it says that web page is not available, okay? Let's look at it again, and the container is live because the Kubernetes itself made sure, hey, you wanted this pod to be running, I'm gonna make sure the pod is running, I'm gonna make sure the container within it is running. Now if I go ahead, access the page here, and the page is live. So that's sort of a pretty cool feature of Kubernetes, where it self-heals, auto-restarts your containers if needs to be.
Arun, how does Kubernetes work with scaling? Does it scale based on load?
We are coming to that.
Oh, okay, sorry.
That's going to be a recipe as well. Now, as I said, a single pod is ephemeral. Typically, well, in this case, because I'm running on Vagrant, I have a single host running, but typically you will have multiple hosts running. So a pod could be scheduled on any host, and if a pod is ephemeral, you can't really rely upon an IP address. Well, that's where the concept of service comes in handy, because service effectively abstract a set of pods as a single IP and a port. So you could say, hey, run my multiple pods together, and I'll show you how do you run that. But once you run them, then you can say front end these pods with a service, and it basically creates environment variables in other pods by which you can refer to that service. So think of this as a Docker links, which was working on the same host, but this worked across hosts. That's pretty cool. And essentially, any other pod or application that want to use this service can actually refer to that service as a given IP address. Behind the scene, what happens is you are looking at this service. It is assigned an IP address. You can use an IP address, and under the hook, it uses the IP table magic to forward it to the service where it's actually hosted. Now, that pod may move from host to host, but Kubernetes will ensure that that proxy, so to say, from service to that pod is maintained for you. So my second recipe in that case is I'm running on the same minion, but now I'm running two pods. There's a Docker pod, there's a Wildfly pod, there's a MySQL pod, okay? But instead of referring to MySQL as a IP address, which is ephemeral, I'm going to front end my MySQL pod with a MySQL service. And I got my MySQL service over here. So effectively, if I look at my configuration file here, this is my MySQL configuration file, and I'm giving a label here, and then in my service, I'm giving a label as well. So this kind is service, this kind is pod. So here is my MySQL pod, here is my MySQL service. Then when the service is started, you get the IP address of it. Remember, it's an environment variable. So using that environment variable, you can access it in your Wildfly application and create a JDBC resource. Now, you can configure, as I said, your kubectl script to say, hey, by the way, don't create just a minion, create multiple minions. It can do that. So once multiple minions are created, this would very well work across host as well. So you can say, set up my MySQL service. This pod might be on this minion. This pod might be on different minion. It doesn't matter really. But once the pod is there and the service is accessible, that IP address mapping is maintained for you. So Simon, you were asking about, how does it scale based on the load, etc. So, well, that's where the concept of replication controller comes in. Well, now, replication controller ensures that a specified number of pod replicas are running. Okay, all it does is it uses a pod template, which you specify how the pod template is going to look like, and act as a cookie cutter on that. It schedules the pods, across hosts. Those algorithms are pretty standard right now, but the discussion that I'm seeing is those are going to be made more configurable. We saw how we can manually scale the replicas by running that command kubectl scale, giving it a number of replicas, or it can auto scale as well based upon the load. But that's purely Kubernetes driven. I haven't played with it yet, but I believe there is a mechanism by which you can provide an algorithm on how it should scale up and down. Another cool feature that I still have to play with it, gosh, there are so many tools to play with, a rolling update feature of Kubernetes. So you can set up 2 parallel services, using some label magic. You can +1 on the old one, -1 on the old one, +1 on the new one, -1 on the old one, and that way you can start slowly removing your old containers out and start creeping in your new containers in. So it has that concept. So stay tuned for more details on that a little bit later. Not in the presentation, but in the next few days. So let's see what my recipe 2.4 is in that case. Well, here you go. I'm creating a Wildfly controller. This is a replication controller. I'm saying 2 replicas, and this is my template. And here is my Wildfly service. And because I'm using the selector as name Wildfly, and here the label is name Wildfly, I'm creating a service over 2 Wildfly nodes here, or 2 Wildfly pods. So service over 2 Wildfly pods. So effectively on minion 1, now I'm just using both the pods in the same minion, but it's completely independent on how Kubernetes schedules these pods over different minions. But effectively you have 2 pods, both running Wildfly, front-ended with a Wildfly service. This is going to be a front end to your web application. Both of these guys, these pods could be using a MySQL service, which is front-ending a MySQL pod. So as you're recognizing more and more, service is the design pattern that is recommended, because that is a more standard that allows you to scale up and down. You can add more pods, you can remove more pods, you can add replication controllers, you can remove replication controllers based upon your need very easily. So what are the pros of Kubernetes in that case? Well, Kubernetes allows you to manage all the Docker containers together as a unit. You can say, hey, create a replication controller, replicate it. It allows you to do container communication across hosts, which was sort of one of the basic limitations of Docker as well. We looked at how it allows you to scale up and down across hosts. However, that's not good enough. So what are some of the issues here then? Well, Kubernetes does not give you a full life cycle of application. I'm a developer. I just care about NetBeans or JBoss Developer Studio or IntelliJ, and I want to build my application. You do whatever you want to do under the hood with Docker, Kubernetes, all that stuff. But give me my build, deploy, manage, promote cycle. So that's missing from Kubernetes. There is a lot of code existing today in the world. people are using Docker images, Kubernetes configuration files, Maven projects, blah, blah, blah. How do I port all of that to run in this environment? There is no such mechanism available. I'm missing the full DevOps cycle here. How do I do my dev to test to production? Docker gives me all those goodies, but I need somebody to build tooling on top of it to give me that benefit. There is no multi-tenancy today in Kubernetes. And there are certain features that are only available as part of Google Compute Engine. That means only on-premise, that are not part of Kubernetes open source project. Okay. So look at this. Then here, my typical application is, as I talked about service, I have a web service with 2 Apaches. I got a Java EE service with 2 JBoss pods. I got a database service with 2 MySQL pods. I got a messaging service with 2 ActiveMQs. How do I compose all of this together as one? Well, meet OpenShift. That's what we call as an OpenShift application. So OpenShift is Red Hat's open source platform. OpenShift 3 released this year will provide a holistic experience of running your microservices using Docker and Kubernetes. At the bottom is Atomic, that provides an end-to-end solution for deploying containerized application quickly and reliably with Atomic update and rollback for application and host alike. Well, the core of Project Atomic is the Project Atomic host. This is a lightweight operating system that has been assembled out of the upstream RPM content. OpenShift basically adds developer and operational centric tools on top of Kubernetes and Docker to enable rapid application deployment, development, and scaling. And it also does long-term lifecycle maintenance for small and large teams and applications. Let's take a look at it how. It gives you full push to prod, basically full DevOps capability, that as soon as you push your code to a Git repo, you want to go production, and all of that is done underneath using Kubernetes, Docker, all of that. So all of Kubernetes, OpenShift 3 is built on top of Kubernetes and Docker, and that's where our contribution to the upstream Docker project or the Kubernetes project is very, very useful. It gives you client tools for building web applications. It also provides you a centralized administration and management of application component libraries. So you have a Git repo, so you play around with that. And I think the important part is how it provides isolation of containers, and it encapsulates the network capability, network communication that is not available, that is not so easy to configure in Kubernetes in a very easy and multi-tenant system in OpenShift. So let's take a look at my recipe 3.1 in that case. Now, OpenShift you can run natively as well, but hey, I'm a Mac guy, so I again like to run things light. So you can start up OpenShift as a Docker container. Very straightforward. Just use the command which is shown in the box over here. So you can fire up your OpenShift origin, as we say, because that's where all the open source is done, for OpenShift at least. And in a very classic Red Hat way, everything is done in open source first. So OpenShift origin is where all the content is being contributed. So you can run your OpenShift origin using a Docker container. There are binaries available by which you can run natively also. But the first recipe is, if you have your Docker and Kubernetes file figured out, then you can use them as is in Kubernetes, in OpenShift. We have this thing called as OSC, or OpenShift client. So instead of using kubectl, it provides binary compatibility, all the capabilities of kubectl in OSC, and you can use your Kubernetes configuration file with OSC. Well, that doesn't give you all the value that OpenShift provides, though. So that's where recipe 3.2 comes in handy. Now, if you look at it here, it can take a look at your existing your configuration file, and from that, it can generate a project configuration file. So it's a full-blown, well, this is basically one JSON configuration file. Now, remember, we were talking about application operating environment and how I could have multiple components that need to be assembled together to build an application. Well, this is in Kubernetes. There is no such concept of a top-level configuration file. This is exactly what OpenShift provides. So here I'm highlighting, for example, content service. This is a GitHub repo URL. I'm using STI called as source to image, which automatically picks up your source code and generates an image out of that. And here I am. What is it? I can't even read it. Oh, this is the MySQL port, MySQL server. So, excuse me. So in this one configuration file, you've specified everything and anything that you care about and get it running over here. Okay. So if I can take a break here. So now what I'm going to do is I'm going to get out of my previous shells here. Okay. So if I look at, say, Docker PS here, it says that my OpenShift origin is running already. Okay. So we don't need this here. 192. Now by default, I have OpenShift running. It's still a very, very early version of OpenShift that I'm playing with. So, but at least you will get a user experience of it. So I have, I logged in here. So I mean, there's a blog coming on this soon, so stay tuned. But all I did was created a simple project here. I got a project OpenShift 3 sample here. Now in this, well, I'm running I've created a project. In this project, what I can do is I can easily take an existing Git repo. From that Git repo, I can populate, which will generate the configuration file for me. Okay. So what I need to do is now, if I can look at my notes here for a second. Yeah, I need to grab the container ID. So here we go. So now all I'm going to do is I'm grabbing the container ID for the OpenShift origin. So all I'm going to say is get into the container. Now I'm into the container now. Here I can say show me what containers are running within the OpenShift container. Now remember, this is the OpenShift container which is running a Docker as well. So now I'm in here. So if I go back here, I have mapped some local workspaces here. Okay. Oh, not here. Sorry. Okay. So this is my Java EE 7 HOL. Here is my application template JEE build. I know the name is ugly. Needs to get fixed. We literally got this rolling yesterday. So there is no such thing as JEE. It's got to be Java EE. We'll take care of that. But here is where your configuration file is. It's a long configuration file, but there are tools available which will allow you to generate this configuration file from an existing image. Okay. So I'm going to go back to my notes here, and all I'm going to do is I'm going to fire up a command here. You know what? I'm thinking I'm going to go back. We're running out of time almost. So I'm going to go back to the slides here and show the snapshots that I captured earlier. So effectively, once you populate the project on the fly, you see there is a front end, there's a MySQL part that is created for you automatically. Then you can fire up a build, and it runs with it, and it says the application is available to you live. So this is basically showing you the full dev to prod cycle, how you can easily simulate that using OpenShift. And literally all you do is you make a change and push it to your Git repo, and the full development cycle goes through. Now recipe 3.3 is where what I'm excited about is how this is going to be all integrated with JBoss Developer Studio, because effectively that's my end user tool. So when I fire up my JBoss Developer Studio, I just want to talk with the Git repo, and something underneath needs to happen. Whatever it is, that is up to the runtime layer. So summary. Docker is used for container runtime and image distribution, but we looked at the pros and cons of Docker. Kubernetes allows you to roll your solution for anything that you want. You can have multiple Docker images talking across multiple hosts. It provides full runtime and operational management of containers, but we saw how it misses some of the key concepts from the application developer perspective. And that's where OpenShift comes in handy. It provides you a full DevOps of life cycles and how you can have thousands of applications that can be easily manipulated within a team using OpenShift online itself. So the references, anything that I've talked about today is available on my blog already. So this is the URL that you want to handy. You can try most of the stuff over there. Otherwise, I will continue to blog on this topic. And if you want to get started with OpenShift Origin, I'm going to be blogging about that soon as well. So stay tuned on that part of it. Right. So I think I am done at this point.
And also, Arun, if you were to pass me the slides, if you got a link on SlideShare or something like that, I can make them available to the wider jug as well.
Okay, I'm going to go back to Hangout here.
So questions. We actually have a superstar in IRC today called Despair, who has been giving some Docker sessions recently and also uses it day to day at work. So he's been answering loads of questions in IRC, which has been some great discussion in there as well. Here's one question. On the one hand, this setup is bringing portability and easy creation of VMs or containers, but aren't we more capable with Puppet, Jenkins, and VMware? And actually, sorry, he follows up as well with Docker is certainly helpful.
I understand the question. I get the question. Yeah. So see, I think the thing that you want to understand, VMware, again, you are tying in to a vendor. Puppet is definitely good. Puppet, Chef, all of those things. But is that sort of your broader part of a solution? Does that give you portability? You really have to install VMware on a particular vendor. Do you want to go with a different environment? Do you have that portability? So with using Vagrant and Docker, it gives you that portability where you don't have to rely. And see, I think the fundamental difference you need to understand is how Docker itself is fundamentally different from a virtual machine. We're not even talking about a virtual machine. We're talking about containers, just having a Linux operating system, and on top of that, leverage the power of Linux operating system and run containers on top of that, instead of running multiple guest operating systems on top of a host.
Okay, awesome. Another question from Timo. How does Docker or Kubernetes handle different architectures? So, for example, ARM processors. Despair mentions he's run them before on ARM 7HFs. I don't know if you have any other insights as to what they run on.
No. I've been playing around with them for about past 6 months now, mostly running on my Mac so far. I guess I should be trying to run a Kubernetes cluster on a Raspberry Pi. That seems to be a fad these days.
Yeah, you need to get on to Simon about that. I'm sure he's probably done it. Okay, question from Sounds of Silence. Is there a way to define functional dependencies between services with any of the tools? So, for example, if he upgrades his MySQL schema, would it automatically restart other services that the dependencies exist between?
Now, that's an excellent question. See, I think the Kubernetes by itself does not provide that functionality. Now, that's the kind of functionality you would expect, like OpenShift or JBoss Developer Studio to provide. Not JBoss Developer Studio, but more like OpenShift, because that's the higher level DevOps kind of a functionality. That's what OpenShift is looking at it. So I would highly encourage to, I'll take a look at the IRC chat anyway, but maybe file that as a use case for OpenShift team.
Okay, cool. Yeah, Despair mentions also at the moment it's kind of like almost like a roll your own on that sense. Yeah. Question from P. Grazio: does it make sense to mix Chef with Docker?
Mix Chef with Docker. I haven't played with that actually, but you could certainly do that. You could use your Chef recipes to roll out your Docker containers. I don't see an issue with that.
Okay, and Despair actually mentions that he's using Puppet currently to configure their Docker application. So I guess there's That's more of a flavor choice between.
Yeah. So you pick your favorite flavor. Puppet, Chef, Ansible, Salt. You pick your flavor, and these are all provisioning tools. Whether you use VMware for provisioning or VirtualBox or Docker, they're just a layer under.
So we've run out of questions in IRC. I've got a question of my own, Arun. So if we actually look at across everything that you've shown us today, from OpenShift all the way down to for example, Kubernetes and Docker and boot to Docker and Vagrant, Fig, Cube, all these tools. There's a lot to learn for a developer. Is this kind of like almost similar to a microservices style architecture, where in actual fact the pain is in maintaining it, and the pain is in it's not as simple to run and just get started with. Is there concerns that it's not going to be capable for developers to get up and running quick?
Right. So I think that's an excellent question, because I don't expect developers, specifically anybody who's building an application development, to learn and understand the concepts of Docker and Kubernetes to the core. As long as you understand at the high level, Docker is a container, Kubernetes allows to manage those containers. I would expect developers to look at tools like OpenShift, where they say, hey, I want to build an application, and I got some existing investment in Docker and Kubernetes. I just want to leverage it. So let me see how OpenShift helps me with that. Because from a developer perspective, your focus should be, again, on building application and your business logic, rather than worrying about the infrastructure. Now, OpenShift, Docker and Kubernetes, because of isolation, snapshotting, versioning, security, all of that goodness, they do enable microservice architecture, and OpenShift certainly leverages all that goodness and enables that for you. So I think as a developer, you should really be looking at OpenShift as a platform on how you can get started and then get a feel for the flow. And then if the need be, then there is material always available.
Do you see a tool that's going to rise, which is going to be more capable of taking on all of these tasks, or do you still see in a year or two's time needing to have this many tools in conjunction?
This many tools, you mean?
Yeah, this many layers.
Yeah. Well, I mean, at this point of time, I think OpenShift is the only PaaS that I'm aware of that is using Docker and Kubernetes to its core. There's, of course, Google Compute Engine that is also looking at it, but they don't have a very good support for Java anyway. So for Java developers, I think OpenShift is a very, very credible and the real opportunity. I definitely want, as a developer, to dumb it down further and simplify the application development lifecycle. Don't tell me all that garbage that's happening underneath the hook. Just get my job done. I want to focus. Effectively, what I'm looking at is, here is my Maven project. Yes, you're using Docker Kubernetes. Show me that my carbon footprint has gone down by so much by using Docker Kubernetes. That's what I care about.
I think we're running out of time now, so what I will do is I will just quickly share my screen just to show you what. If I do that and share my screen quick, just to show you what we have. Hopefully you can see my screen now. So a massive thank you to Arun Gupta again for another awesome session. I'll be making the video obviously available straight away. We'll be doing a Rebel Labs write-up, including the interview, which we'll do straight after this with Arun, and also a whole bunch of links, including links to Arun's blog and his slides and so forth. And that's well worth a follow at Arun Gupta on Twitter. Next week on the 17th of January, slightly revised time, it's 6 p.m. We might be joined by a Jug live this time, so I'll talk about that later if that happens. But this is going to be a session on the live reflection madness, which is all about reflection in Java, how to invoke, create classes very, very explicitly without actually typing them. and also how to create dynamic proxies and that kind of stuff. So this is going to be a really, really cool session, and very, very low level. Dr. Heinz Kabutz is the speaker, who is an absolute rock star speaker as well, just like you guys are all used to on the VJug these days. And that's, as I say, next week, 17th of Jan. Sorry, that says January. That should say Feb. 17th of Feb at 6 p.m. So that just leaves me to stop sharing. To say, Aaron, thank you again very, very much for joining us on the VJug for an awesome session. There's so much to go through, I know, on Docker. It seems like you could probably talk a day on this and still have, plenty of aspects that you can learn on the topic. So, thank you very much. From IRC, everyone absolutely loved it. Everyone learned a lot. So yeah, thanks for joining us again, Aaron. And if you stay on the line, we'll do an interview straight after this. So
this was a pleasure speaking again.
Awesome, thank you. And thanks to Oleg, who's been on Twitter. And we will conclude We'll conclude now and speak to you again next week. So thanks, everyone.
Thank you, Aaron.